Welcome back. Let's recall Fubini's theorem that allows us to express the double integral of a function f over a rectangular region R as an iterated integral, where the iterated integral consists of two single variable integrals with respect to x and y. The question that I ask here is whether we can extend Fubini's theorem to more general regions. And the answer is yes, we can when the region is either of type 1 or type 2. So a type 1 region is called a vertically simple region. A region D is called vertically simple if it consists of points xy where x lies between two constants a and b, and for each x between a and b, y lies between g1 of x and g2 of x. So here is a typical type 1 region here. So you can see that x is between a and b, and y is between the graph of g1 of x and g2 of x. Here the value of g1 and g2 are different at a, and also g1 and g2 they have different values at b. In the second graph, the only difference is that g1 and g2, they have the same value at a and b. In the third one, g1 and g2, they have the same value at a but not at b. So we could also have the case where they have the same value at b but not at a. But they are all vertically simple regions. And when we have a vertically simple region like this, then the double integral of f over a vertically simple region D is equal to, can be expressed as an iterated integral where we integrate from a to b and from g1 of x to g2 of x, f of xy dy dx. So we need to first integrate f with respect to y. So the inner integral is with respect to y. Once we compute that, we're going to get a function of x only, and then we integrate that with respect to x. Now the reason the region D is called vertically simple is the following. So x is between a and b here. And if we fix an x value and make a vertical line at x, then the vertical line will intersect the region D at a vertical segment, line segment here. And notice that as we can think of as x goes from a to b, we can think of D consisting of this vertical line segments. So that's why it is called a vertically simple region. Okay, so there is a type 2 region that's called horizontally simple region. So a type 2 region so D is called a type 2, or D is called horizontally simple if D consists of points x and y where y lies between two constants c and d, and then for each y, x lies between h1 of y and h2 of y. In this case, the double integral of f over d can be expressed as an iterated integral, where we have the integral from c to d, integral from h1 of y to h2 of y, of f of xy dx dy. So the inner integral is with respect to x. So we integrate with respect to x first, and then we're going to get a function of y only, which we're going to integrate with respect to y, and that's going to be the value of this double integral. Notice that in both cases, the outer integral, the limits of integration for the outer integral are constants in both cases. And in the case of the vertically simple region, we integrate with respect to y first, and in the case of a horizontally simple region, we integrate with respect to x first. All right, so in the next video, we'll be doing some examples to illustrate this extension of Fubini's theorem.